So. Yeah, pon atención. Yeah. Good afternoon, Andres. In today's class, we will address a fundamental topic in neuroanatomy. The basal ganglia, key structures involved in the integration of movement, posture, and certain aspect of behavior. Please, if you have some question, could you ask me?
Okay.
Before we begin, I'd like to briefly share what we aim to achieve in today's class. No, these are the class objectives. Okay. First, we will focus on identify the basal ganglia from an anatomical perspective. Then we'll relate this structure to their main anatomical relationships, which is essential to really understand where they are and how they interact with surrounding areas. No? We'll also review their blood supply. No? Is very important and an important point from both an anatomical and clinical standpoint. No? And finally, we can, as we can see, we'll explore their basic functions so we can connect the structure with function and clinical relevance. Let's start with a practical example. Okay. In this image, we can see a brain. In the following image, can you identify the basal ganglia? Maybe could you identify the basal ganglia?
I think I can't quite remember.
Okay. We're going to explain, I'm going to give you more information, and after I'm going to put again the same image. Okay? The term basal ganglia is currently considered outdated. Since technical, these structures are not true ganglia. They are subcortical gray matter structures adjacent to the encephalo and closely relate to the ventricular system. And they may comprise 5 nuclei. Okay? Among. Then we can see in this image the thalamus. No, next to the thalamus we can see the putamen and the globus pallidum. Okay, as we can see, caudate nucleus is the green one, putamen is the blue one, no, and globus pallidum is the next one. So this is a charcot cut. This image as the same of this, but in different perspective. But we can realize that if you put in the same place putamen and globus pallidum, we can have the lentiform nucleus. So the caudate nucleus and putamen, the two one are called striatum. No. When you put in the next striatum and globus pallidum, you can call this group corpus striatum. And if you want to complete with another structures that the people generally call basal ganglia, you can put the amygdala and claustrum. Okay, so in this image you can see putamen, globus pallidum, maybe the thalamus, and caudate nucleus. This is the cortex of the brain. So please, more phylogenetically, that is from the oldest to the most recently formed. There are 3 groups: archistratum, neostratum, and paleostratum. Functionally, we can see 3 things that you can see in this case: claustrum, amygdaloid nuclear, caudate nucleus, and putamen. No, and globopallidum. These are three groups that we can classify from functional aspects. So we can different groups that I'm going just to read because it's not important. Lentiform nucleus, corpus striatum. These groups are striatal complex and these groups are pallidal complex. So here we are again with the basal nuclei image. Can you tell me which ones you remember? Just two basal nuclei. Can you identify?
Yep, I think it's putamen, and this one is globus pallidum.
Perfect. No? It's more easy when you have some information to identify in this case. So here we are, another question. I'm going to read for you. Which of the following brain structure is located adjacent to the caudate nucleus throughout its entire course? Thalamus, amygdaloid complex, hippocampus, lateral ventricle.
I'm pretty sure it's lateral ventricle.
Okay, maybe yes, maybe not. I'm going to give you some information, and with this information, I want that you answer again. I'm going to put you the same image. Okay, the corpus striatum, which we mentioned earlier, is composed of the putamen, globus pallidum, and caudate nucleus. It closely relates to the lateral ventricle, which is a cavity filled with cerebrospinal fluid and is mainly located around the caudate nucleus. In addition, it relates to the internal capsule, which carries a projection pathway known as the pyramidal tract. This is the pyramidal tract, this is the cortex, this is the thalamus, these are the basal ganglia. So, in this, here we can observe the same structure shows in the previous image, but in a corner section, which allows us to better understand the anatomical relationships. Okay, so among the basic anatomical relationships that we should know, we have the globus pallidum, that is this one, with two divisions, no? External and internal part, also referred to as medial or lateral part. Okay, the putamen is lateral to the globus pallidum. Okay, maybe the caudate nucleus has a head, body, and tail. It's very important, no? The amygdalin is in the head of putamen. Okay. Here we have the thalamus and subthalamic nucleus of Lewis. Here we can see another structures that have a stretch relation with all these basal ganglia. So, in this part we can see the internal capsule, the third ventricle, the lateral ventricle, has all the structure. See? And if you analyze again the question, we can see, no? Which of the following brain structures is located adjacent to the caudate nucleus throughout its entire course? As you can see earlier, the lateral ventricle is located adjacent to the caudate nucleus through its entire course, no? So the lateral ventricle is the correct answer, no? And I have the last question. I don't need that you answer in this moment this question, no? I'm going to give you more information in this moment, you can give me the answer. Regarding the blood supply of the basal nuclei, which option is correct? They receive direct blood supply from the internal carotid artery. You can see after. The circle of wheels is not involved. Their blood supplies includes both anterior and posterior circulation, and the thalamus receives its blood supply from the anterior circulation. Okay? So, if you see all the structures, you can see all the structures of the basal ganglia. So, in this part, we can see the vessels structure. So, regarding arterial blood supply, as we will observe, the ganglion basal receive blood supply from both anterior and posterior vascular system. This is anterior, this is posterior. From the anterior vascular system, the vessels involved are the middle cerebral artery and the anterior communicating artery, which are the terminal branch of the internal carotid artery. So, from the posterior system, the posterior cerebral artery is involved. No, this is the posterior arteria, posterior cerebral artery. The anterior communicating artery gives rise to several branches known as the anterior perforating arteries, among which most will know is the recurring artery of Hübner. This is the Hübner, no? And as the same, we have another ones arteries, as you can see. No? It's very, very important, all these arteries. In this table, you can see a summary of all the arteries. First, mainly because I don't know how to say, principalmente para que tú puedas observar, para que tú puedas analizarlo luego, ¿sí? For that you can analyze after, I put this table with the summary of all vessels for this. Regarding the blood supply of the basal nuclei, which option is correct? Can you answer with the information provided?
Their blood supply includes both anterior and posterior circulation.
Perfect, no? As we can see, the anterior has a carotid intern and posterior has cerebral posterior, no? So, the third one is the correct. Their blood supply includes both anterior and posterior circulation, no? If you can analyze the functional neuroanatomy, maybe you can tell about all the circuits that have our brain, no? Having reviewed the anatomy, we will now analyze the functional neuroanatomy. These basal nuclei act through circuits or loops in which 5 elements participate. No, the first one, maybe the first one element that you can see are the cerebral cortex. Then you have a basal nuclei. So another basal nuclei, so you have the thalamus, and finally you have again the cerebral cortex. No? All these are the loop that complete the functional neuroanatomy. So we can see some 4 circuits, mainly 4 circuits that have specific functions like skeletal motor circuits, visual circuits, prefrontal circuit that have like functions, the executive functions, and limbic circuits, no, that have like function that mainly function the motivational. So in this image you can see like the the like this one, a motor circuit, oculomotor circuit, prefrontal circuit, and limbic circuit. No, it's very important. The first one is the cerebral cortex in all of them, and the last one is the cerebral cortex in all of them. No, the first one cerebral, and the last one is the cerebral cortex. This is very very important. So in this image, summaries how I put this image summaries of how movement is organized in four stages: planning, programming, executions, and control. Planning occurs in cortical areas, mainly the prefrontal and somatosensory association areas. No? Programming is carried out by the basal nuclei and the cerebellum in this place, which modulate movement initiation, posture, direction, and amplitude through the thalamus. Execution takes place through the brainstem and spinal cord. No? Brainstem, spinal cord, activating the skeletal muscle. So finally, control, this one, is achieved through feedback, mainly involving the cerebellum, allowing coordinating precise movements. So I think that that is all. No, that's all that I want to show you. And in the conclusion that you can see, the first one, I can see that at the encephalic level we can identify the main basal ganglia structures, the caudate nucleus, putamen, and globus pallidus. In addition, we also find related structures such as the amygdala and the claustrum, which complete the anatomical organization of this region. The second one, conclusion, I can see that to identify the basal nuclei, it's important to understand their anatomical relationship. As we can see, the structures are closely related mainly to the thalamus and the lateral ventricles, which helps explain both their location and their functional connections with the brain. And the last one, as you can see, this part is from a vascular perspective. No, it's important to highlight that the basal nuclei don't depend on a single arterial source. Instead, they receive blood supply from both the anterior and posterior cerebral circulation, which explains their complex and clinical relevant vascularization. To conclude, I'd like to thank you for your attention and participation today. As Richard Feynman said, science advances when the complex becomes understood. I hope this session has maybe helped make the basal ganglia a little clearer and more meaningful for you. No, that's all. Thank you.